Welcome to the first of a series of videos that I shall be producing on behalf of Soltis. These videos are designed to provide easily accessible briefings to non-technical people, teachers, educational leaders, administrators, publishers, to the world of technical standards for e-learning. Now, teachers are very used to people talking about educational standards, meaning how good an educational experience is, how good a school is, whether you're going to pass your Ofsted inspection. When we talk about standards in Soltis, obviously we're not talking about that kind of standard at all. We're talking about an agreed way of doing something. And one of the first distinctions that need to be made is between de facto standards and de jure standards. De facto standards are standards which have become ubiquitous in practice without having gone through any formal consultation or ratification process. Common de facto standards are things like Microsoft Windows or Adobe's PDF format, where adoption has been driven by a particular successful proprietary technology. The advantage of de facto standards is that they are, by definition, widely implemented. So, for example, a developer who creates a Windows program can be pretty confident that it's going to run on a lot of people's machines. Their disadvantage is that they are often controlled by a particular player in the market, who may use that control to disadvantage competitors, skew the market, and inhibit further innovation. De jure standards go through a consultation and ratification procedure to make sure that they're fair, but if no one implements them, and that's surprisingly often true of standards which are driven by academia rather than industry, they're not really very useful. So good standards need to combine the best of both worlds. They need to be created through a procedure which ensures that they're open and fair, but also which ensures that they're actually going to be implemented. And the best way of doing that is to make sure that industry itself plays an important part in the procedure, so that the standard reflects genuine industry requirements. Another way of talking about standards is to divide them into quality standards and interoperability standards. Quality standards are an attempt to codify best practice. ISO 9000 is an example which represents an approach to quality management. We think that there is an important place for standards which define a minimum level of quality, which ensure, for example, that what you've just bought isn't going to explode in your face or involve you in unforeseen legal liabilities. But creating standards which define best quality is much more problematic. What represents best quality is often subjective. It's often different in different circumstances, and it often changes rapidly as technology advances. Quality standards often attempt to impose one person's view of what is required on everyone else, and there's a real danger that they inhibit innovation and diversity. So what in Soltis we're really interested in is not quality standards, but interoperability standards. One of the best analogies for what I mean is BS1363, the 3-pin plug. This allows me to plug any electrical appliance into my mains electricity supply. It could be a toaster, a hi-fi, a telephone, a foot spa. I can buy it from wherever I like, I don't have to ask anyone's permission, and I can be confident that when I get it home I can plug it into my main supply and it will work first time. Imagine for a moment what it would be like if we didn't have the standard for the 3-pin plug. Let's say I got my house wired by British Gas. I would have to go back to British Gas to get the British Gas approved hi-fi, the British Gas approved telephone, and if I wanted the British Gas approved foot spa, well, I guess I could probably forget it. And if that seems like a ridiculous scenario, that is exactly what we have at the moment for infrastructure-dependent learning technology in schools. Whether we're talking about electrical appliances or CDs or DVDs or computer software, without the underlying interoperability standard, there is no open infrastructure. And without the open infrastructure, there is no market in the infrastructure client or content. And if there's no market, that means that you, the consumer, have no power to choose the product that you want to buy. So much for the why. I'd like to talk now a little bit about the what. Interoperability between learning programs is obviously not about the flow of electricity, it's about the flow of data. Allowing data to flow from one place to another comes down to agreeing how that data should be formatted, and that agreement is encapsulated in a set of specifications. There are essentially two ways to create that open data format. One is to create an open file format. A well-known example of this is ODF, the OpenOffice Open Document format. A document created in one word processor can then be opened reliably and edited in a completely different word processor. Open file formats are generally about avoiding lock-in to one program and are about interoperability between programs which essentially do the same thing. There's obviously a very important place for open file formats, but one criticism that can be made of them is that they can come to represent a kind of lowest common denominator, which may limit further innovation. If, for example, I wanted to develop a new feature in my word processor which required some extra data to be stored in the file, I would find that very difficult to do while continuing to support the open file format. Even if I managed through a long process of consultation to get everyone to agree to my new data format, I would then have lost any proprietary advantage, any opportunity to get a return on the investment that I had made in developing the new innovative technology. So in an emerging market like learning technology, where there's a lot of scope for further innovation, the open file format may be of limited use. What is potentially much more productive is runtime interoperability. This covers the situation where two programs are running at the same time, each doing different things, each using their own proprietary file formats, each application, if you like, running as a black box, but each having a requirement to talk to the other. For example, a quiz may need to send a student's score to a markbook. The agreed data format is then not a file format, but a message format. Runtime interoperability is a very important concept because it allows the development of innovative new technologies which can nevertheless talk to each other. And that sharing of data is absolutely essential in the school environment. One final confusion that it would be worth sorting out is the difference between open standards and open source. Open interoperability standards are about agreed data formats. Open source is about publishing the source code of an application so that anyone can modify the application and make it behave exactly as they want. Open source introduces a new business model which depends on the provision of a service rather than the supply of a software product. But open source is not in itself about standardization. On the contrary, as it allows anyone to change the underlying code of a program, it could be seen as the opposite of standardization. Where open source and open standards meet is in the complaint made by some open source providers and proprietary suppliers for that matter that they have been unfairly excluded from markets by the control exercised over critical data by existing proprietary suppliers. Open standards will remove any distortion from the market and allow open source and proprietary models to compete on a level playing field. To return to the electricity analogy, you'll be able to plug in a proprietary toaster or an open source toaster, and they will both be able to get access to the essential infrastructure services that they require. So in this briefing, I have discussed the difference between de facto standards and de jure standards, concluding that you need to aim for the best of both worlds, the difference between quality standards and interoperability standards, concluding that with the exception of minimum standards, we think that quality standards should generally be avoided, the difference between open file formats and runtime interoperability, the difference between open standards and open source, and by using the analogy of the 3-pin plug, explained why interoperability standards are an essential prerequisite to the creation of new markets, and why interoperability standards are about supporting diversity and not about enforcing conformity.